Welcome students to a walkthrough of Excel so that we can do the calculations for the normal distribution as I had promised. So what I'm going to do is I'm going to talk about each of the examples. And the first one I'll just do quickly is the refrigerator one, just so you can see where that value came from. So let's say here we have X is approximately normal. In this case, it was 14 and 2.5. So that's the mean and standard deviation. So here I'm going to type in mean and standard deviation so that we know what these values are. And right here, let's put 14. Here we'll put 2.5. And then here we'll do normal calculation. So what we have to do is we have to think about which way we're going with this. And there's a formula in Microsoft Excel where if you type in equal norm, so that's for normal, and then .dist is for distribution, and a parenthesis. And once you hit this parenthesis, you'll see down here, it has X, mean, standard deviation, and cumulative. So it gives you a hint as to what should come next. So in this example, we had 17 years. So we're going to type in 17 for our X. That was a value that we're interested in. And we are also interested in the mean, which is 14, the standard deviation, which is 2.5, and cumulative, we are always going to put true. We're not going to deal with false because we're not going to do a specific value. We'll always do an interval. So if we close that up, we're going to get a value that I did not have on that sheet. So the reason for that is that Excel always calculates the cumulative frequency up to the value. So that means all values left of the specified value. So we're gonna, let's just make this a little bigger. Here we can wrap it. And now we can read it. So what's going on here is that on that graph, it's going up to 17 instead of more than 17. So now if we want the probability of X being greater than 17, which was the problem, we'll do equal 1 minus this to do the complement. And as you can see, the value we get here is 0.11506967, which in that graph on slide 12, if you look at the PowerPoint, was 11.51%, which is just a rounded version of this. So that is for the refrigerator example, the first one. And now we're going to move on to another example of the reading rates. So the reading rates had a few, we'll just delete these here, start over. Let's clear these cells. And let's clear this one. And here we're going to specify it a little bit differently. For the reading example, we had X is normal with 125 as your mean and 24 words as the standard deviation. So here I'm just going to specify that so we can see it. And we'll have the normal calculation, which will be the equal norm.dist. And here, what are we trying to calculate? So in this case, for part A, we were trying to do X less than 100. And that's going to be really easy because that's what Excel gives us. Remember, Excel gives us anything up to that value. So we'll start all the way to the left, unbounded, will accumulate from 100 all the way down. Or you could think from all the way down there up to 100. It depends on which way you want to view it. But either way, this is the way that the normal distribution function works. We're interested in 100, the mean of 125, the standard deviation of 24, and again, true. So this will get us the probability of X less than 100. So that is 0.14878, which if you remember in the slide on the PowerPoint 14, slide 14, it was 0.1488. So this actually is the exact thing we want right here. So now let's look at probability of X being greater than 140. Now this is where the normal calculation has a problem. So we're going to do norm.dist and we're going to say, okay, we want 140. We have our mean, we have our standard deviation, we have true. So this gives us the value in the problem, the mean, standard deviation, true. And that gives us, if you look at your sketch, a value that's much too high, right? It should be much smaller than 73%. So we realize it must be the complement. So the value in this case will be 1 minus that. You could also come up here, and if you wanted, you could do 1 minus, and it'll take care of it. So you can also put it right in the original equation. Sorry, put that there. And we can get rid of it there. So as you can see, you can do the 1 minus that whole calculation, and Excel will still be able to handle this norm.dist, even if it's in the middle of an equation. So that's really reassuring. Again, if you look at the PowerPoint slide 15, you'll see the value was 0.2660, which is just this rounded. All right. Now let's see, what other problems do we have? We had between. Okay, so this is going to be a little more interesting. So here we have the probability of 110 less than X less than 130. Now this becomes a lot more difficult because now we have an interval, and Excel's really not that great with intervals. There's 2 steps that need to happen. So if you think about where Excel adds up values, this one's going to be a little tricky, because if it goes up to 110, that'll give us everything less than what we want. And if we go up to 130, that gives us part of what we want, but too much because we didn't want anything before 110. So if we instead view this calculation as the probability of X being less than 130, but not being less than 110, if we get rid of that part, then we can use the normal probability distribution. So in this case, we're talking about equal norm.dist. We're going to go up to 130 first. So we're looking to go up to 130, all true, with the mean standard deviation. And then if we subtract off the part that we didn't want, that it accumulated too much of, we can subtract off the part that we don't want. And if you look, that gives us 0.3165, which is exactly what slide 16 had. So we have to rewrite this in terms of this, just like we had to rewrite this one. Let's be more explicit here. 1 minus the probability of what we don't want. So here we're being explicit as to how we're using it. So in this case, this we rewrote as 1 minus up here, as you can see. And for this one, we rewrote it as follows so that we can handle it in Microsoft Excel. All right, let's look at another example, X greater than 200, just for more practice. Again, we're going to do 1 minus X because we can only write less than. So think of Excel as only writing less than statements, and if you can't, you have to create less than statements. So here there were too many things going on, so we need to do 2 less than statements. Here it's a greater than, so we're going to create a less than by using the complement rule. So this is equal to 1 minus norm.dist of the value in question, the mean, the standard deviation, and true. And this gives us the value that we had on slide 17, which was 0.0009. So hopefully that was informative. The next couple examples we're going to do are going to involve the normal distribution. I'm going to show you that the refrigerator example matched. So if we're switching now to a Z, which is normally distributed 0, 1 always, that's the default, then for calculations, you just need norm.dist and it'll default to this. So if we did the refrigerator example, where remember it was probability of X being more than 17, this can be rewritten as Z greater than 1.2. which we also know needs to be written as 1 minus P of Z less than 1.2. Now let's try this calculation here. So we're going to do norm.dist. And we're going to do, equals 1 minus norm.dist. And we're going to do 1.2. And if we do true, oh, hold on. And we still specify. So 1.201 true. Guess it doesn't default. We'll get the same value that we had before. So again, we know the mean, the standard deviation, which will be 0.1. I think what I noticed when I was typing that is if you wanted to do the shortcut, I bet this is it, norm.dist. Yep. So that S stands for standard distribution. You could just do 1.2 true, and there's the default one. So there are two ways to do it. Either norm.dist with the mean standard deviation of 0.1. I think it's easier just to stick with the one command, norm.dist, and always specify the mean standard deviation. But if you want the shortcut for Z, it's just norm.s.dist, and that will give you the shortcut. And we only have a few more examples. Let's keep practicing. So suppose we want the probability of Z less than 2.90. So this is in the right form. It has that less than sign. So this will just be norm.dist of 2.9001 true. Again, for me, I just like using one formula, so I don't have to remember anything else. And that matches exactly what was on slide 20 in the PowerPoint. If we wanted to figure out probability of Z greater than negative 0.55, then we have to rewrite it. So in order for Excel to handle it, we need to do the complement rule because we need it to have a less than sign. So hopefully the complement rule is really familiar to you. It comes in handy in this situation. So this is 1 minus norm.dist, negative 0.55, 0.1, true. And that gives us that value that we want. And last but not least, we had the probability of negative 1.67, some Z less than 0. And I had said, try to figure this out on your own. Why I put 0.5 minus 0.0475. And that's because of how Excel sees this. So we need the probability of being less than the biggest possible value. So 0, we're going to add up all of that, but we didn't want anything before negative 1.67. So we're going to subtract off anything that came before negative 1.67. So we're going to type in equal norm.dist. 0 came first, 0, 1, true. We're going to subtract off norm.dist of negative 1.67, comma 0, comma 1, comma true. And that will give us the 0.4525 value that you saw in the PowerPoint slide 22. So in closing, if it has less than, it's just norm.dist with that value and the mean and standard deviation. If it's greater than, we need to apply the complement rule. If it's an interval, we subtract the bigger portion and then subtract off the smaller portion that we counted that we weren't supposed to. And all of that can be written with the norm.dist to calculate it. So this one's a good example. So try it out, do some practice. There are plenty of practice problems to try in the assignment section. And I encourage you to keep working with Excel and get used to norm.dist. It's a very powerful tool that we're going to keep using. So get comfortable with it. If you have any questions, let me know. I hope this video was helpful, and I will see you at the next video.